Hey, this is Logs Day 4. We're going to talk about transformations and domain and range. So we've talked about transformations so many times this year. It feels like we've talked about them every single unit. So this should just be mostly review for us. But for our domain and range, we have to talk about it specifically for logs and what that looks like. So I said before, logs and exponentials are inverses of each other. So when we have inverses, we're just switching the x and the y. So for logs and exponentials, it's still the same thing. So domain and range are just domain is our x values, range is our y values. So if we look at the domain and the range of an exponential and we flip that, it should be the same for our log. So the general function, just log of x, looks similar to this right here. So we have our x and our y axis, and then our function for our log just looks like this. So it's kind of almost opposite of an exponential. Like if you turn the paper 90 degrees and we flipped it the other way, it would kind of look like exponential decay there. But so this is our function here. So there are no transformations here, obviously, because this is the general function. So for our domain, remember our domain is just our x values. So for our x values, just like with an exponential, they have an asymptote, so do our logs. So our logs, as they go left, we're getting closer and closer, but we're never actually touching the y-axis here because we have an asymptote. So for our domain, we're getting closer and closer to 0, but we're never actually going to have an x value of 0. So if we're doing interval notation, we can say it's going from 0 to infinity. And we know that infinity always has a parenthesis. And then for 0, since we're never touching it, it's not actually included. So we're also going to put a parenthesis there. It's not a bracket because a bracket would tell us that 0 was included. So since it's not included, I put a parenthesis. Okay, so there's our interval notation. We can also do it as an inequality. And we can just say that x is greater than 0. It's not equal to because it can't be equal to 0, but it's x is greater than 0. So now for the range, okay, our range here is our y values. So for our range, you can go all the way down, you can go all the way up. So for our range, it's just going to be from negative infinity to positive infinity, or we can say all reals. Okay, so this is what we're basing all of the rest of our transformations off of, is this domain and range. So for our first question here, we're gonna first describe our transformations, and then we're also going to state our domain and our range. So if I use a natural log, if I use just log log, it does not matter since we're talking about the transformations. We're talking about the differences from what we started from. So if I give you the natural log of x minus 2, okay, remember this minus 2 is what's changing. So we just need to figure out, is it going up, down, left, or right? So this is not considered with the x here. So I can put this in parentheses. They don't have to put it in parentheses, but this x and this negative 2 are not connected. So this negative 2 is technically like on the outside. It's not with the x. So this is going to be down 2 because it's minus and it's on the outside. So it's down 2. So now for our domain affects our x values, whereas down is affecting our y. So if I took this function and I just shifted it down 2, it's actually not changing my domain at all. So my domain is still going to be the same as it was. It's going to be from 0 to infinity. Okay, and you can use interval notation. You can use inequality notation. I'm going to stick with interval just because that's the one that you're usually going to see. So for our range here, I went down 2, but since I'm already going from negative infinity to positive infinity, it does not matter that I've shifted down 2. My range is still going to stay the same. We're just going to say all reals because nothing changed it. If I shifted it down, it doesn't matter. Now it's here, but it's still going from 0 to infinity for the x values, and it's still going all the way down, all the way up. So our range is still going to be all reals. Okay. Now for question number 3. Okay, we have x minus 2 on the inside here though. So this minus 2 is with the x. So that's going to affect our domain, our right and our left. And remember, when it's inside the parentheses, it's the opposite of what you think. So if it's negative, it's going right. So we're going right 2. And like I said, that's going to affect your domain. So if I was going from 0 to infinity, and then I shifted right 2, now instead of having an asymptote at 0, it's going to have an asymptote at 2. So I'm going from 2 to infinity because I shifted everything to the right. So instead of being at 0, I shifted it 2 to the right, which means it's from 2 to infinity now. And then again, range has not changed. Okay. Number 4. So this one we're going to have 2 different transformations, and we're going to see what that's going to do. Okay, so we have y equals log of x plus 3 and then plus 1 on the outside. So this plus 3 on the inside, remember that's on the inside is our right and left, and it's backwards. So plus 3 is going to tell us that it's left 3. And then this plus 1 is going to tell us that it's up 1. Okay, so then my domain is affected by the left 3. So if I was at 0, I shifted it left 3. Now I'm going to be from -3 to infinity. And then my range, again, same thing. It is not changing. It's all reals. It includes all of our numbers. So it's just going to stay all reals for that. And then we'll do one last one. Same type of thing. And remember, if it's a natural log versus just a regular log, it doesn't matter for your transformations. Just like if I gave you 2 to the x or 3 to the x for your transformations for an exponential, the base doesn't matter. So here, the log is just saying the base is 10. Remember, for the natural log, it's saying that the base is e. So the base doesn't matter. It doesn't affect it. We're just looking at what extra things did they add in here. So this -3 here is telling me that I'm going right 3. And then this -1 on the outside is telling me that I'm going down 1. Okay, so then for my domain, the right 3 is what is affecting my domain. So my domain is now 3 to infinity, and my range is all reals. Okay, so for our transformations, it's the same rules as always. If it's with the x, it's left and right, and it's opposite of what you think. So left is plus, right is minus. And then on the outside, what's not included with the x, that is going to be your up and your down, where positive is up, negative is down. So for domain and range, you're just using those transformations to figure out how it shifted from the original, where your domain for your original is 0 to infinity, and then the range is -infinity to +infinity. And then you're just looking at how it shifts. Your range should really not be changing at all. It should be all reals. And then for your domain, it's just going to be 0 to infinity. Whatever your domain changes would have to do with your shifting left and right. Okay, so check out your homework. Make sure that you are following your notes to figure that out. And I will see you guys for day 5.